main stage. It's my great pleasure to be able to introduce Javier Blanco Cordero from Quix. He's a senior data scientist at Quix, which helps customers get the most out of their data science projects. He was previously a senior data scientist at Orange, working on churn prediction, marketing mix, and propensity to purchase models. And he's also a lecturer on a master's course and speaks on pragmatic data science, causality, and real-time processing. So, over to Javier.
Thank you, Charlie. Well, welcome everyone to real-time processing with Quix Streams. Or we are going to learn today how we can work with real-time data, that is, data as soon as it's produced. Charlie has already presented me, so yeah, I'm Javier Blanco, I'm Senior Data Scientist at Quix. At Quix, we are trying to make data streaming easier, but we'll go into that in a sec. That's the challenge for today. This is what we are going to try to be building. So picture bike-sharing company, like there are so many, and we want to detect the event of a crash. So we want to detect if a customer has crashed their bike, to offer assistance, to maybe inspect the mechanical state of the bike. We are going to do it through the data that the customers are sending with their phones. We want to create a Python service with some logic. It could be a machine learning model that is listening to that real-time data and creating the event of a crash. Obviously, we want to react to this event fast. This is a case where it's not OK to wait until midnight to run a batch process and say, oh, yeah, there was a crash at 12 a.m., right? So for real-time detection, for real-time processing, we are going to need to work with streaming. And I like to ask you, how many of you are experienced with streaming technology? So Kafka topics, pub and sub patterns. Let's see those hands. OK. This is more than usual, so pretty good. But still, I'm going to make an introduction to those of you who haven't raised your hands. Let's see what streaming is, and let's compare it to the more traditional way of working with data, batch. So in our use case, the one we have just presented, if we were working the traditional way with batch, with a database-centric process, things will look something like this. You see that customer app, it has just generated a data point, and that's sent somehow to a database. And from that point onwards, that piece of information is static, is resting in that database. And the user keeps cycling, and at some point, there it is, it generates another point that gets sent to the database, and so on. Life keeps going on, the data keeps generating in real time, but we send it to a database and it gets stored there. It gets stopped there for a while. Until we reach certain time, we are going to call it time t, where we actually query all that data that has been resting in the database. And we query from our processing system. And our processing system can be our Jupyter notebook locally. It could be a script that we have in the cloud working in production. It can be anything. It's just the code that is going to process our data. So we load that data in memory, and now we are ready to do anything. We could, for instance, add a new variable that total G acceleration forces, which is an absolute sum of each axis acceleration. Or we could add a delta acceleration, as you see there, which is giving us how much the total acceleration has changed from T2 to T1, T3 to T2, etc. My point being, once we have queried the data in memory in our processing system, we can do anything with it. We can do any statistical analysis, any machine learning training, etc. This is the way we are used to work, and there's nothing wrong with it. Only that if you look at what we are doing, we have had to wait to Tn to process the data from T1. So we are inserting some delay. We are waiting to process the data, and in some cases, this could be crucially wrong. So for those cases where the data of the value is going to decrease over the time that it takes you to act on it, like in the bike example we are covering, we can use a different architecture. We could use streaming. In streaming, as in batch, data is generated in real time, but instead of sending it to a database for it to be stored and stopped, we send it to something like a Kafka topic. This is a totally different infrastructure where some entities publish data to and others subscribe to listen to it. So you see our processing system there. Again, could be our Jupyter notebook locally, could be our script in the cloud. But you see how it's subscribing data in real time. So the moment that the data point got created, we have it in our processing system. And this is great because at T1, we can process the data and create these new variables, these new features, like total acceleration that we did in batch. And it's too soon to calculate the deltas. We are just at T1, but we can wait for T2. And when T2 happens, we will be able to calculate, again, the total forces and also the delta accelerations. However, this is key, and this is where streaming is actually challenging. You see that for us to calculate the total forces at T2, we had to keep in memory the total acceleration forces at T1, right? Because in streaming, we get the latest point of data, we get it as soon as it's produced, that's great, but we only get that one. So if we need more information to perform our calculations, like here we needed the previous value for total accelerations, we need to keep that in memory. In streaming operations, that's called state. Good. So is that clear? What batch is, what streaming is? Nice. So let me introduce you to Quix now, because at Quix we are trying to make streaming as simple as possible. Those are our four founders, and they had this vision from their previous company. They were all Formula One engineers at McLaren. So you can imagine this is a rapid environment where they need to react to data in milliseconds. However, the data analysts, the data scientists, the people who had to create the business logics, the data science models, they couldn't handle the real-time data because of the infrastructure that it needs, the completely different mental shift. And from that idea of making streaming easier for people like data scientists, Quix was born. And we have two main lines of work. The one above, Quix Streams, is the one I'm here for today. Quix Streams is an open source Python library that allows you to work with real-time data very simply. I'm going to be showing it today. I hope you like it. I hope you become contributors. And we also have a SaaS platform, which is a more complete solution where you get observability on your Kafka topics. You get Kubernetes plus Docker for serverless deployments. You get samples of code. Everything is there. So I'm going to show you how you can work with real-time data with Quix Streams, as I was saying, but I just need to tell you about two more concepts for those of you who are not familiar. So topics, that's the first citizen in a streaming architecture. This is the place where we're going to be publishing data, subscribing data from. This is our substitute of a database. Data is not stored in there, it's not persisting in there for a long time. It goes through it. Think of them as pipelines or highways. Now, at one side of these topics, we are going to have the publishing entities, those that send data to the topic. And at the other side, we are going to have the subscribing entities, those that consume data from the topic. And having said that, we are ready now to publish some data in real time. So I'm going to open this notebook, this collab. And you see I'm starting with the classical pip install Quix Streams. That's the open source Python library that I was referring to. So that's installed, happy days, and now I'm importing our classical pandas as PD and also Quix Streams as QX. Good. The first thing that I'm going to do is I'm going to create a client. This client from the Quix library is going to allow me access to this real-time data by being able to subscribe or publish to the topics. So I'm creating that client. This client can refer to your Kafka infrastructure in the cloud, or it could be your Kafka locally. And now I'm going to create an entity, a producer. As you see there, I'm using the recently defined client and then get topic producer. So what I'm saying is I'm creating an entity, an object that is going to be able to send data, to publish data to that test topic. Remember, I said topics are like pipelines or like highways. So there's one final concept that I need to tell you about. So if that was our topic, our highway, and we have some data points flowing there in real time, there can be instances where the processing that we want to do over the data is a bit slow. If you think about it, pretty much any processing is going to be slower than just letting the data flow, right? So imagine we have some process here. I'm going to simulate it with those speed limits that make the data flow go a bit slower. If I speed this up, you see what is happening, right? We are getting a queue of data. And just as you will do in a highway when there's a toll, we do the same in streaming. We basically add more traffic lines, just like that. And that same speed is not causing a traffic jam anymore, right? So with topics, it's the same. That topic is our highway, and we have to create a stream now to actually send the data specifically to that traffic line, okay? And as you see, I'm getting the topic producer, create a stream, and that's my stream, just there. And we have defined everything that we need to. We are ready to send data. So I'm going to create some random data frame. As you see there, it has a timestamp. It has a parameter A and a parameter B. Publishing this data frame to that Kafka topic is as simple as pointing to the traffic line, to the stream that I want to send the data, then dot time series, because this has a timestamp, dot publish, and I send the DF. As simple as that. And to show you that that data is getting sent somewhere, I'm going to keep that over here. That's our line. We haven't run yet. And I'm going to open Quix, the platform, as you see there. Good. What we see there are different topics. So we are going to focus on the test topic. We don't have any data coming in, as you see there. And what I'm going to be doing is I'm going to click there, and we should see right there in test topic some data going through, some bytes. So I'm going to click there, and let's see. There we are. That's some point of data. I'm going to send it again. There we are, right? So I'm sending data in real time. But looking at a line is maybe not that exciting. So I'm going to ask your help to be producers of data. I'm going to open this chat up. And I'm going to ask you to take your QR code readers and join me in that chat. Basically, your phones are going to become data producers into Kafka topics. And we are going to be playing with that for the rest of the session. Let me just show you that this works. Yeah.
Enter space, capital E, capital S.
Okay, I see some people joining the chat. Great. Yeah, join there. Good.
Don't mind me, guys.
No worries. I see some people reading the QR. Yeah, keep going. And whilst you do that, let me just show you what we are doing. So that chat room, that is listening to two topics. One of them is that chat messages one, okay? And your phones are producers. So just the same way that I was generating some data point, your phones are. Every time you send a message, you are actually publishing that message to that chat messages topic, which the chat room is listening to, is subscribed to. And I'm gonna prove it this way. So this is the sentiment app. I have the worst of the splitter configuration set up. Okay, that's our chat room, right? I'm gonna now create a message from my collab and send it to the chat, just to prove that we can publish data to that topic, the chat messages, very simply. So client.getTopicProducer, and I point to the topic that I wanna produce data to. That is my topic producer object. And now remember, it's not enough to point to the highway, I have to point to the specific line. In this case, that chat is powered on that specific DSF line. That's what I'm creating there. And then it's as simple as DSF stream, that stream that I have just pointed to, .time series, .publish, and I send the data frame. As you see, the data frame that I created has a column called chat message, where I can send my text, hi there from collab, and it has a tag name with my name. So I'm gonna send this, and we should see it there. There you are. That's the latest message, as you see. So I'm just trying to show you how with code, you can publish very simply with Python, you can publish very simply data to a topic. Once we know how to publish data to a topic, let's talk about how to listen to data from a topic. So I have this other notebook to do just that. And I'm gonna start creating a client, as we did earlier. This is gonna be the entity that is allowed to listen to topic, publish to topic, etc. Earlier, I created a topic producer. It's the same that I'm doing here. But now I'm also going to create a topic consumer. So this is the opposite. This is an entity that is listening to data in a topic. Good. And with that, we can do this thing that I'm showing here. So we can do the topic consumer, we can ask it to do something every time we receive a new stream. Remember, streams are the highway lines. So every time there is a new line, do this. What do we do then? So whatever we're defining here. And what we are defining is every time there's a new line, listen to the data coming in and react with that, which is this function here. So basically, you can forget about everything we said. This is where we process the data coming in real time. So I'm just going to display it. I'm just going to show it. So I'll hit play. And I'm going to ask you to send some messages to the app. We should see them there. There we are. That's one. So you can see I'm listening to a Kafka topic in real time. This is very hard to do. This is very hard to do without something like this. This is something a data scientist like me couldn't ever do, really, because I will have to learn Java. I will have to learn about certain infrastructure that I just don't know about. But with Quix Streams, I'm using Python in a simple enough way I can access to data in real time. And now that I can listen to data in real time, and I can also publish data in real time, if I listen to data from one place, process it, and then publish it to another, I have a real-time processing system, okay? And that's what I'm doing here. Instead of just displaying the data, you see there, I'm using pandas normally to modify the chat message column and make it uppercase, just something stupid. And then instead of stopping there, I'm sending that modified message to the output topic. So if I run this, that's running, and we go back to the chat. Please send some messages. You see what's going on. It seems we are angry at each other, but we are just processing those messages in real time. And this is a silly example, but I want you to think in the possibilities. It's powerful. It allows you to react to the data your business is producing in real time without depending on very complex infrastructure. Cool. Let's see. No. So, good. I hope that made sense. As I said, it was a little silly example, but this could be something meaningful, like here. I'm going to deploy that code. It's doing something similar to what we have just seen, but instead of just listening to the data and making it uppercase, it's using a sentiment analysis model to calculate the sentiment and then calculate the sentiment overall. So I'm running that. As you just saw, I hit the deployment. If we write something now, you see we have sentiment analysis add to our chat. You can try that. The point being, the processing can get as complex as you want, but the concept that I really want to show is that you can work with real-time data as soon as it's produced. If you want, I'll tell you why those back and forth points happen. We all have different internet connections, internet connection speed. So for those that are slower, we are sending the timestamp when the data got produced, but maybe that data point is actually arriving to the cloud a bit later. Nevertheless, you get the idea. Let's do a final demo. Let's do a final demo where we see how we can react to data in real time. So for those of you Android users, if you want to participate creating telemetry data for the demo, please go to Google Play and download this app. You can uninstall it later. With this app, you are basically going to generate telemetry data, G-forces, Wi-Fi, speed, that type of thing. So I'm going to connect myself as well. And we are going to be working with that telemetry data in real time. So I don't know if anyone wants to install it. No? Yeah? Okay, I have some volunteers there. Can you raise your hand, see if you're doing it? 2, okay. Good. So, is it download? Yeah? Or is it downloading? Is it done? Okay, just searching. Yeah, yeah. So, yeah, can you find it? Okay, no worries. I'm going to do it with my app just to make it a bit quicker. So, I'm going to start a connection. I'm doing that right now. And you see that phone data topic is getting some data coming in, right? And I could have a look at what that looks like. And you see what kind of data it's sending. So I'm going to focus on the acceleration forces. And those are the real-time acceleration forces. If I move my phone around and then leave it on the table again, you see that's my phone. So if I flip it over, you see the acceleration forces change accordingly. So we are working with real-time data. This is the power of streaming. And now, you remember the use case we started with? I'm going to react to that real-time data by processing the data and then generating some model prediction to detect shaking. So you see there, I'm using normal pandas to calculate the total g-force acceleration. This is a line of code that you are very familiar with, just normal pandas. And then the loaded model that I had trained, I'm using it to predict based on those features. And with that new column, what I'm doing is I'm only reacting when shaking is detected. So when shaking is detected, I send data to the next topic. If shaking is not detected, I do nothing. So I'm going to go back to the deployment. And you see I have it running. And you see data is coming in, right? Data is coming in through that phone data topic. I could look at the specific messages. So that's real-time data coming in. I can select one of those, and you see it has the specific acceleration forces. But what we don't see is any sort of data in the phone events. That's the output topic that will only get data publishing if I shake my phone around. So let's see if that works. I'm shaking my phone, hey, and there you see, we get some alert saying, hey, you are shaking your phone. So I'm gonna have a look at those messages, how they look like. You see we are listening to phone events now. Nothing is going on until I shake it. And suddenly we have those alerts there telling us phone shaking from Javi's phone. So you get the idea. We are generating data in real time. As soon as that's produced, we are listening to the data in real time. We are processing it. We are predicting with machine learning models, and we are outputting results in real time. This is what I wanted to talk about today. As you see, we've used Quix Streams all around. This is an open source project that we would love you to help develop. And if I can ask you to use your QR phones one last time, it will really help us if you start our repo and help us grow our community. So thank you very much, and I can answer any questions now.
Thanks, Javier. Very interesting talk. Would anybody like to ask some questions?
Thanks. Is the platform free to use as well?
It's free for personal use, like your side projects and testing around. For commercial use, like big flows of data, several people working on a team, roles and so on, is not for free. It's a commercial solution. Yeah.
Thanks. Thanks for the talk. So, a quick one. How would you say it's different from other frameworks like Apache Beam or things like that?
Good one. So, this is focusing on the data scientist point of view. And that goes a long way in everything we do. We try to make it very Pythonic. And as you see, I was using data Panda frames. So you can use pandas, you can use scikit-learn. It's really batch approach within streaming. So not SQL, not using of tables. Most other libraries are focusing on that. We are focusing on giving data scientists and analysts a batch-alike experience. That's pretty much it.
Thanks. And another one, is the processing itself happening inside of Kafka, or is it something that's sort of pulling the data out of Kafka, running the processing and put it back into a new stream?
It's happening outside of Kafka. So what you see in the platform is basically a marriage between Kafka and Kubernetes. So you read the data and then publish it out to another Kafka topic. There are some functions that we have straight out of Kafka, but the simple question is it's outside. Thanks.
Any other questions?
I did a quick browse of the repo like before the talk, and thanks for the talk.
Thank you.
I just couldn't find any like documentation how you might like self-deploy on your own infrastructure. Could you give a bit more insight on that?
So you're saying that you had a look
To
at
deploy
our
the
docs and you
platform,
didn't find anything?
I couldn't find like options on deploying, like if there's any like architecture diagrams to delve into ourselves. If you want to say deploy a platform in your own.
Okay, that's great feedback. We can have a chat later. But yeah, we have docs as you have explored, and we are growing a lot now as a team and putting a lot of effort in improving them. So we also have some other channels where you can make ad hoc questions, like if we are not covering in the docs, we have a Slack channel that you can access through the platform just there.
But is it possible to deploy on your own infrastructure?
Oh yes, yeah.
Okay.
Yeah. It is. My point being, we can help you if you don't find something in the docs. You can ask for that and we will publish it later, or you can ask in that Slack and we will answer pretty much immediately. Thank you.
Thank you.
Thank you.
You said about the pipeline of data. On that, you said it saves the memory from the first data. Like in the pipeline, you said it has a memory of the initial value.
Yes. Yeah. So in streaming, you read the data as it's produced. So if an app has just produced a point of data, you are listening to that point of data. And imagine that is the price that a customer has paid for some burger. Okay, so you have 20 pounds. That's the latest value. Now imagine you wanted to do, for your model, one of the features is average price of the last 10 purchases. If you wanted to calculate that in batch, it's quite simple. You have a table, you do a rolling window operation, you have your feature. In streaming, because you just got the latest point, you just got that message saying this burger was 20 pounds, you don't have all the previous ones. So if you really wanted to calculate the average over the last 20 purchases, you'll have to have kept those previous 19 purchases in memory. And that's fine. There's nothing wrong with that. We do it, we support it in the open source library to make it easy. But it's just something you have to think about that you don't have to think about when you work with batch. Does that make sense? Yeah. So with streaming, you can work in real time, but you have to be thinking about these things. Yeah. Yeah.
I was wondering if, with your architecture, have you ever evaluated what's the sort of like trade-off between doing something server-side versus doing something client-side or at the edge? Because, for instance, like in the example that you showed, right, where you were shaking the data, the rate at which you were shaking the phone was higher than the sort of like streaming rate, let's call it.
Yeah.
So it would only show you like, you know, very generically, like, you know, maybe 1 or 2 points instead of like the full, you know, frequency resolution. So I was wondering, like, you know, roughly what size of model do you think you can eat on the two different, obviously there are a lot of like caveats in like what type of architecture, embedded, not embedded, but, you know, if you can just give us some like idea of what they trade
Yeah,
off.
I cannot give you a specific number, but if you wanted one, we can have a chat later and I could message some numbers. But yeah, for the sake of the demo, if you think about what is going on, that deployment is working in the cloud. And we are listening to that from Wi-Fi here on my laptop, and I'm sending the data as well with Wi-Fi. So I didn't want to have a high frequency just to make the experience a bit.
That's perfectly understandable.
Yeah.
My question was a bit like, obviously, like,
yeah.
like
Where is the limit, right? So coming from a Formula One background, the limit is very, very high. They work within milliseconds sometimes. So it's not the edge, but it's the closest you can get, basically. For more specific numbers, let's talk outside, and I can have a look at some.
Yeah, thanks.
Thank you.
Okay, looks like we've exhausted the questions. Let's thank Javier again.
Thank you. Thank you.